Hello there. In this video, I'm going to start us off by doing a quick visual proof of how we can derive a formula which connects the gradient of a straight line with the angle that it meets with the x-axis. So if I get my line tool and draw some kind of random straight line like this, and I then put 2 points on this line. So if I say, take for example, I don't know, this point here and this point here. Okay. Now I'm going to impose a sort of right angled triangle onto these points, and we'll see why that's useful in a moment. But this triangle I will define as being right angled. And what I'm concerned with, what I'm interested in, is this angle here. Because if I can find this angle here, that's a really bad theta. If I can find this angle here, then if we remember back from maybe a couple years ago now, this is an F angle because this line is parallel with this one, so finding this angle would be the same as finding this angle, which is the angle between the straight line and the x-axis. Okay, so we have a right angle triangle, and I'm concerned on finding this angle. Well, if we remember back from National 5, and even if you've done National 4 then there as well, if we have an angle and we have two sides of the right angle triangle, then we can actually find the angle using SOHCAHTOA. So what I'm going to do is try and define two sides. So if I take, for example, let's suppose that this coordinate here is, let me see, 712 as an example. This could be anything, but I'll just call it 712. And this point here will be at 3, 4, let's say. All right. If I wanted to find the length of this side, I would take the 12 and subtract the 4, and I would get that this is 8. So in general, you take the y component of the second coordinate, y2, and subtract the y component of the first coordinate, y1. I'm going to get rid of these coordinates now because that's going to get in my way. I didn't mean to get rid of that straight line. There we go. So, and then in this one here is like, let's say we said that was, I think, 7 and that was 4, I think it was. So if we took 7 minus 4, we'd get the length is 3 of this side. So in general, we have that the length of this side here is x2 minus x1. And these coordinates then would just simply be any two coordinates. So you'd have x2, y2 there, that's the second coordinate. This is the first one, so you have x1, y1. And okay, so let's use SOHCAHTOA. So here we have opposite and adjacent, so that's OA, right? So that's TOA, that's the tan ratio. So we'll say tan theta equals opposite over adjacent. Tan theta equals, right, the opposite is y2 minus y1, and the adjacent is x2 minus x1. But then if we look at this side of the equation here, y2 minus y1 over x2 minus x1 by definition is gradient. So we can replace this with m. Tan theta equals m. Because that's the formula, m equals this, right? And then you can flip that around to m equals tan theta if you want, but it doesn't really matter. And so now we've developed a formula relating the gradient of a straight line and the angle. So if I know what the angle is, I can find the gradient of the line. If I know what the gradient is, then I can take tan inverse and find the angle of the line. That's the idea. So let us take an example. In this example, we have 2 points. And what I'm interested in is what would be the angle of the straight line in the positive direction of the x-axis which connects through these 2 points. All right. So if we just sort of visualize this, let me sketch this out. So this is a visual representation of these 2 points. So here we have the point C 0 minus 5 and the point D 7 minus 4. And if I were to connect these 2 points with a straight line, then we would get something that looks like, there we go. So now what we're interested in is finding this angle here, which is between this straight line which connects those 2 points and the x-axis. So as we just proved from earlier, we have the formula m equals tan theta. So if I want to find this angle theta, I need the gradient of this straight line. Unfortunately, I have 2 points, so I can find that rather easily by using the y2 minus y1 formula. Just be careful, we're going to have minus 4 minus minus 5 here over 7 minus 0. So minus 4 minus minus 5 will be 1 over 7. And then using the m equals tan theta, or in this case maybe I'll just write it this way, tan theta equals m, and then we'll have tan theta equals 1 over 7, and so therefore theta equals tan inverse of 1 over 7, and theta is therefore approximately equal to 8.13 degrees to 2 decimal places. Taking a second example, we have the points A, B, which is A, 10, 2 and B, 8, 7. And again, we're being asked to find what is the angle between this straight line, well, the straight line which connects these 2 points and the x-axis. So again, we know that we use m equals tan theta when we're talking about straight lines and angles with the x-axis. So when I find the gradient, I'm going to get 7 minus 2 over 8 minus 10, and then this will be 7 minus 2 is 5, and 8 minus 10 is minus 2. Now, this is clearly a negative gradient, so when we have a negative gradient, do we remember that, well, first of all, let's put it into the formula. So we'll have tan theta equals m, and so tan theta equals, I'll just say that's minus 5 over 2, right? Same thing. And remember that we don't solve this. What we're going to do instead is take some other variable, say tan A. You can name it anything you want. So tan A equals the positive version of this, 5 over 2, and then take the inverse tan as usual, 5 over 2. And when you work this out, you will get 68.2 degrees. That's rounded to 2 decimal places. 68.2 degrees. But remember that this is not the solution that we want. This is not theta, this is A. So then we have to use the cast diagram. Okay, so we have cast. This is 0 and 360. This is 180. Now this was negative. So tan is negative when sine and cos are positive, but one thing to keep in mind, if we actually visualize this angle, let's have a look at what it looks like. So here, since we have a line with a negative gradient, I don't really need to draw this to scale. I'm just going to draw some straight line with some negative gradient. And again, the angle that we are interested in is the angle which you start from the line and you go in the positive direction of the x-axis until you hit it. So this is what we're always interested in. Now you can see, if you look at the cast diagram, there's 2 possible solutions when we solve a negative tan. We have between 90 and 180, in other words an obtuse angle, and we have between 270 and 360 degrees, aka a reflex angle. Now clearly this will never be a reflex angle. This will always be between, in this case, since the negative gradient, it will always be between 90 and 180 degrees. So essentially we say, right, well, we know that it has to be obtuse, so we know that it strictly has to be in this quadrant. So in this case, this is the only quadrant we use, and because it's a geometric interpretation. This is not just solving a generic tan theta equation. This actually has a geometric meaning. So we have to take that into account as well. Now, you don't actually have to think of it in terms of the cast diagram every single time. You can just remember it as you find this angle here and then take, because by the way, this angle here, I'll just mention, this 68.2 is this angle, okay, this angle here. So that thing there is A, that's 68.2. And you can see you have a straight line with 180 degrees. So you can just take, as you would do with the cast diagram, take theta is then 180 minus 68.2. And that's going to be, let's see, 120 minus 8 is 111.8. So that's 111.8 degrees. And that's this angle here. But you can just really remember this fact here. But you can, if you want, it might be nice for you to actually do that in your thing, but I think they accept that you just do 180 minus this angle here, and it's perfectly fine. In this last example, we're going to be coming at it from the opposite way. So instead of being asked to find the angle with the gradient, what we're instead being asked to do is what's the gradient given that we have the angle, okay? So this is an easier question because we already have the angle and we don't have to do anything other than plug this into this formula. So m equals tan theta. This time we know what theta is, so we can say that m equals tan of, in this case, 37.1. And plugging that into a calculator, we will get that the gradient of this line is 0.76.